So one thing that really went viral on Twitter was this 1 million checkboxes application, where basically they have a million checkboxes all displayed. Users can come in here and all get updated live as these checkboxes are being clicked. So I decided to put my own spin on this application called 1 million treasure chests, which you can find at millionchests.webdevcoding.com, where there are a million chests. This is all using virtualization, and I'm using a service called Convex behind the scenes, which by the way is the sponsor of this video, to do the live data updates. So let me kind of scroll down here. And if I were to click on some of these chests on the right, you'll notice that on the left, all users who are currently logged into this application will see that data update in real time, which is one of the many reasons why Convex was such a great fit for building this type of application. Now I will say I added a Easter egg to this application. 10 of these chests open up to gold chests that have a discount code from a Web Dev Cody SaaS starter kit walkthrough. It'll be 100% off, so you'll get the starter kit for free. It is in pre-release, so I'm still working on it. But if you were to click on one of these will have a gold chest. Here we go. And I found one that says the discount code is Hello World. And notice that one of the 10 gold chests have been found. So I'm going to be showing you how you can use Convex to basically build this entire thing out. I'm also using Next.js for the front end to build this out. And I want to give a special shout out to Daria on my Discord for making the sprites for this treasure chest. I think there's a lot of cool things you can learn in this video, including how to display millions of things to a page using virtualization, how to think about some database optimization, such as we are using a bit set for storing all of these toggled on or off chests. I'm going to be talking a little bit about database contention and how you can make your writes more performant when you're dealing with a database such as Convex or just doing SQL transactions, etc. So a lot of cool stuff. I highly recommend to stick around to learn a little bit about this. And like always, the code will all be hosted here in this URL, which I'll put in the description link below. All right, let's just go ahead and jump into it. I hope you guys learn a lot watching this video. So let's start with making a repo. I'm going to go over here and say million chests. And we'll go ahead and just make this MIT and create this repo. Then I'll go ahead and clone down this repo and go to my workspace and just git clone, type in that repo URL. And then we also want to open it. So let's just go ahead and find that. So I'm going to initialize a Next.js application, but you can use Vite or whatever you like to use. So I'm going to say npx create next app at latest and just go ahead and do it in the directory we're currently working in. I'll say yes. I'll just use the defaults for everything. Now, secondly, let's go to the Convex docs and they'll walk you through how to get this set up with Next.js. They also have a bunch of other things you could use if you want to. Let's go to the Next.js quick start guide and we are going to go ahead and install Convex over here. I'm going to try using Bun because it does run a lot faster. So let's just do a Bun install real quick and that'll install all the Next.js dependencies. But again, you can use npm, you can use pnpm, you can use yarn, whatever you want. But then I also want to add the Convex package. So I'll say Bun add Convex. And that should be added. And then we can run it by saying bun convex dev. So bun convex dev should run our application. And it's going to ask you, do you want to create a new Convex project or an existing one? I'll say new. And if you don't already have this linked up to your Convex account, it'll ask you to like log in and like click a link. But after you do that, you can select what team. I'm going to select 1 million chests and that'll create our Convex app. And after you create that, if you go to your Convex dashboard over here, you'll see a new project called 1 million chests. Let's click on it. And now you can use this dashboard to manage your data, look at your cron jobs. You can look at your files that are being stored, check out your logs. It's a very useful dashboard when doing development locally. And also when you're in production, you need to kind of just check out some data or modify some data. The second thing I want to point out is that there is a Convex folder that got created when you ran that command. Okay, and this is where you're going to put all your Convex actions, mutations, your queries, and also your schema file. So let's just go ahead and have 2 terminals going. I'm going to say bun dev, and that's going to spin up our Next.js application. And I'm going to go ahead and rename this to next. And then I'll rename this one to Convex. So let's verify this works. Let's just go ahead and click on this and go and see our Next.js application, make sure it's running. Everything looks good. And let's keep going through the Convex setup guide. There's really like, I think one more thing we have to do. So we need to add this Convex client provider. Let's just go ahead and copy this file and we'll go to our app directory and we'll say, I'll just say providers a little bit, keep it a little bit simple and just paste that in. And then I'm going to call this providers. And notice when we paste this in, there's this process env next public convex URL. There should be a .env file now, which is over here, env.local. And you'll see we have a next public's convex URL. So this is telling Next.js how it can connect to our convex backend and also the convex deployment that we're currently using. And this is just going to wrap all of our children so that we can have access to do the mutations and the queries and the actions from our React code. Let's go to the layout and we'll find that layout directory. Go ahead and paste that in. Again, I call that providers. So let's just go ahead and change it up a little bit. And then we're going to wrap everything inside of the body with those providers. Should be good. All right, at this point, everything should be hooked up. So I'm going to try to approach this problem with the simplest solution, then we're going to iterate on it and make it more performant, make it use less data in our database, and also make it even work with a million things on a page. Because as you add more data, you have to change the way that you're implementing your solutions. But for step one, we're going to keep it simple. I'm going to commit everything real quick. I'm going to say initial commit, just so that all of our files are not green the entire time. Okay. So let's try to display 100 chests. Okay. Again, we're trying to display like gold chests, treasure chests. So let's just say const number of chests is equal to 100. And then we want to basically display all those. So how would we display 100 chests? Well, we could simply just map over an array. So I'll say new array. By the way, I like using Copilot. I think it just helps get rid of a lot of the tedious work. This is basically just creating an array of 100 elements. It fills them all with null, and then we're going to loop over them. So this is like a little hack, I guess you could say, to quickly render out a hard-coded list of things. And let's just make sure that something shows up over here. So this should at least show up like numbers on the page. And now we have a bunch of numbers. So again, we need to make sure this is a grid. Now the way you can do this with Tailwind is the thing wrapping all these elements. We could potentially just say flex. Go ahead and wrap that in a div, and I'm going to say flex wrap. Okay, let's look at this. Okay, now they're all on their own row, and they wrap over when they hit the end of the page, which is pretty nice. But we are trying to do treasure chests. So I have 3 images that someone on my Discord provided me, which we can use to display if there is a chest that's been opened, closed, and if one has been opened that has gold in it. Okay, so that should be pretty cool. So let's just replace this div with a button. And we are going to put a image here. We'll just keep it a normal image, and we'll say chest.png. And let's just see if this works. I'm going to go ahead and just delete this stuff, save the page. And now we have a bunch of chests that are all in buttons. So technically a user could come in here and they could click on one of these buttons, and we need to open it for the user. Now I think it would be nice if we already had like a nice styling. So I am going to bring in Daisy UI. This is a library I've been using recently. Just if you want a really quick way to style your application, Daisy UI is pretty cool. So let's bun add this. Let's just go here on this, and we are going to go ahead and run this in a project that'll add Daisy UI. And it's like 2 other steps to get this set up. So basically inside of your Tailwind config, let's just go ahead and import this. So I'll find Tailwind. Let's find plugins. Let's import Daisy UI, and we need to make sure that we import it at the top. So to verify this works, what we could do is on the button itself, let's just add a button class, and let's get rid of some of this other design that we have here. Okay, so now we actually have buttons, and this is the Daisy UI styling. So another thing that's really cool about Daisy UI is that you can actually come in here and quickly change themes. So maybe Forest might be pretty cool, or like, I don't know, Dracula, something that's like a dungeon, because we're doing like a chest box or something. But basically what you do is inside of your Tailwind config, you have to go to the Daisy UI section. So add one in. Let's just go ahead and do a Halloween theme. That seems pretty cool. So let's just do Halloween. And then the way to set this up is go to your main page and go to your layout. And let's go and put here, we'll say class, I think it's called data theme. And we'll do Halloween. So now our entire application should be themed a little bit differently. I think we have like a background color going on here, so we might have to find out where that's being set. Yeah, we have all this stuff set. We don't want any of this. Let's just delete all this and keep it simple. Okay, and so now you see that we actually have a different theme here. You can actually go back and change this. Like if you wanted a cupcake or something, you could do that, and then go back to your layout and change this to cupcake. And then you'll see that everything changes its theme. And a couple more things we want to do. Let's just put some gap between all these things because right now they're very, very squished together. So let's go back to our page. And on the flex, let's just say gap of 1, just to kind of space these things out. Cool. It might be nice to add a title up here and just like a description of what we're working on. So over here, I'll just say an H1 and I'll say 1 million treasure chests, like this. And then we'll give it a class name of text of extra large. Make sure it shows up. Okay, maybe 2XL. And then also probably some like margin bottom of 4. And then also try to figure out why is there so much padding on this page. This whole page has a bunch of padding on it. So like, let's give it a padding of 4 or something. Move it up. Now also I think it'd be cool to like change the font to make it more like handwritten. So if you go to layout, we already have a way to bring in fonts here. You'll see over here, we bring in enter. There's another one up here that I like called Patrick handwritten. And so instead we could use Patrick over here. I think we just need to give it like a better subset. Let's give it a weight of 400 and see if this works. And we're going to rename this to Patrick. Now when we go back to our app, you'll see there's a nice handwritten text. So let's go ahead and just kind of increase the size of this a little bit so we can see it. And then secondly, we should probably display how many things are checked off. So I'm going to say, I'll just say like 1 of, and I'll say 1 million chests opened. Probably also make that a little bit larger. I changed just the word 1 million treasure chests, 1 of whatever chests open. So let's start getting into the fun part of actually adding in interactivity and functionality to this application. The first thing I want to do is when you click on one of these chests, I want to store in the backend if the chest has been open or not. So one approach to doing this is if you go to convex, we're going to go ahead and just create a schema file. And in convex, a schema is where you can define like what tables you're going to have and what columns those tables have. So very similar to SQL, where you can actually define certain constraints on the columns. So like, for example, you can require that something's a string, something's a number. What we want to do is we're going to copy this example. And we're going to go ahead and just make one called chests. And then we want to just put one called is open. And then we're going to go ahead and just make it a Boolean. And as you update your schema and change your convex mutations and queries, as you save files, you'll see convex over here basically rerun and restart to apply those changes to your convex dev backend. Now, something we can also do is we can store an index. I forgot about this. Let's store an index to track what chest is opened or closed. In the page, when we click on this button, we want to invoke some type of backend logic to add a record saying, hey, someone just opened this chest. Okay, so let's go to convex over here and we're gonna make one called chests.ts. And then we're gonna go ahead and say export const open chest is equal to mutation. And the first time you use convex, sometimes you have to go and manually import something. So let's go to functions over here. They have great docs that explain how to use mutations, queries, and actions, but I'm going to explain them as I kind of build them out for you. Let's import these two, and we're going to be using this generated folder here. So as you like save and change your schema, it's going to regenerate some things, and we can kind of use the generated code to get better type safety. So over here, we're going to call mutation. This takes in an object that's going to take in an args, and then also an async handler like this. So again, we're trying to build out a mutation. And the cool thing about a mutation, if I were to just put a console up here, I'll just say hello, or here, whatever. From the front end, we can import that mutation now. So I can say const open chest is equal to use mutation. And we're going to say API dot chest dot open chest. So notice how we get that auto completion automatically. This is hooking into that generated folder. So we automatically know what API endpoints we can call. So now we have a method called open chest. And if we go over here, we can make an on click on this button and we can just go ahead and call it. Okay, so let's test this out. If we go back to our UI, oh, we are getting an error. We have to add use client to the top of this. I'm just going to go ahead and just keep this simple and just convert this whole thing to a client component boundary. And now when we click on these, let's go to our console down here. I want to show you something very cool. If I click on this, notice that it prints out here. Now this console log, remember this is not being logged anywhere in our JavaScript code. This is actually being logged from our backend. So if we were to go to our million chest dashboard and go to logs, you'll see that these console logs happen in our backend, but because of that convex provider we have in the front end, we automatically get those displayed on the front end. So it kind of just helps with testing stuff out and doing fast iterative development. You can console log in the back and it automatically shows up here in your terminal, but that's a good sign. So the next step is when you click on one of these things, we need to send over what chest index they clicked on. So this one would be 0, 1, 2, 3, 4. So let's go here and we're going to actually add in the index here like this. I'll just go ahead and do this. And now we're going to go to open chest, command click this, and in args, you can actually specify what things a user can pass in to this mutation. So let's just go ahead and say it takes in an index. And the way you can get that value is over here. You can pass in a context and an args for the parameter of the function. And we can just go ahead and print out what args is. So let's do this. We'll save. Then we'll go back and just click on a chest. And notice that it prints out 0. Let me go ahead and do that. It prints out 0 down here, which is pretty nice. And again, the reason we're doing this is so the backend knows what to do when that index was sent over. So how do you write data to your convex schema that we just declared? Over here, you can say await context dot db dot insert. And then we're going to do now let's do a string. We'll say chests, and then we're going to go ahead and just pass in the data. So in our case, we'll say args of index and also is open of true. Okay, that's all you got to do. So now when this mutation runs, it's going to go ahead and insert some data into our database. Let's just click on this once, and then we're going to go back to our logs. We saw that it printed out down here, but then let's go to data. Let's go to chests and notice that we have a record now. So it's pretty nice. So now we can actually use these records to know what chests have been open and what chests have not been open. Now, before we do dive into what a convex query is, I want to talk about an internal mutation just to kind of make sure you understand it's there. If you have some logic that you don't want ever called from a public accessible API, you want to use an internal mutation. And this is useful when we have like other convex mutations or actions invoking internally running things. Okay, if I were to go back here and click this, notice that it's going to crash because we converted this to an internal mutation, which is basically protected in private. Let's go back. We do want it to be public, so let's make it a public mutation. And the next thing we want to do is add a query so that we know what chests have already been opened from other users, and we can display that in our UI. Let's say const get chests. And we'll say query, and then actually I'm just going to call it get chest. This will be a query that takes in an index, so we'll say v.number, and then we're also going to give it an async handler like we did before. Okay, make sure you import query. And the difference between this and the mutation is that this is for fetching data back from the convex database and sending it to the front end. So let's go ahead and just say const chest is equal to await context db.query. We want to get that chest table. And we're going to do something called with index, which I haven't talked about yet. So in convex, by default, you can only get items by the auto-generated convex ID. Okay, so all these things that we're inserting, if you go back and look at the dashboard over here, this has like a unique identifier on it. And you can fetch data back from Convex's database using that ID. But if you wanted to get something more particular like your own data, for example, this index, you have to go and manually create an index on your schema over here. We're going to say index, and we're going to say by index. And then we're going to go ahead and just pass it the column that we want to create an index for, right? So this is very similar to like a SQL index, where if there's something particular you want to be able to query on, you have to manually add an index to it. And then if you go back over here to chests, when we're declaring with index, you'll see that by index already pops up for us. And then we can just go ahead and do a function like this, where we say q dot equals, and then we're going to say index of args of index. Also, we need to do first, so just get the first that comes back. So this is going to query the entire table for every record that matches this. But since it's an index, it's going to be very performant. It's going to come back and just give us the first entry. And now we're going to get the chest. If there is no chest that comes back, we're actually just going to return, I guess we can just return null. Otherwise, we're going to return the chest. Okay, this should be good enough. Again, we're going to do an iterative approach. So some of the stuff we're implementing now, we may refactor later on. Let's go back to our page. And we need to figure out if the chest is enabled or not, like if it is a chest open or not. So what I would probably recommend doing, let's extract this stuff out to its own component so that we can easily link a query to all these chests individually. So up here, I'm going to say function chest, and then we're going to return that button like we did before. And then we're also going to pass in an index, which will be a number like this. And open chest, we could probably just pull this mutation out and put it right here. Again, we're doing all this so we can just do this. And then we're going to pass in the index here. Probably make a key based on the index. And we should be good. Make sure the app still works as it did before. Click on stuff. Still seems to work. Awesome. So what we were trying to do with the query is every time a chest object or component is created, we want to go ahead and just check, hey, is this thing open or not? So let's just say const chest is equal to use query. This is the first time we've used a query in Convex, but it's very similar to a mutation. You can call a method like this. So use query, call the method, and then you can pass the arguments here. So we're saying give us the chest at index 0, index 1, index 2, and then we can tell if it's open or not based on if it's returned. So let's just say const is open, and we're going to say chest question mark is open, because this could potentially be undefined or null. So we want to make sure that we only show it as open if it comes back as defined. So at this point, we have a different image for knowing if the chest has been open. We have chest empty, which we could probably use. So we're going to go over here and say if it's open, then we're going to go ahead and just show, let's just copy this, and we'll say chest empty. Otherwise, we're going to show chest of just normal. Let's just get rid of some syntax errors. Here we go. So now over here, you'll see that these chests are now open. So as users are clicking through this app, trying to find the discount codes, they can just open these chests and these will always stay open. Now, another thing that we want to fix is after it's been opened, we don't want to allow the user to open it again. So we could probably over here say disabled is equal to is open. So if someone opens this already, don't allow them to click on it anymore. Okay. Awesome. Now, I do think there's a little issue. We are just inserting a record every time they click, but we should probably do a check to make sure that we don't open it twice. Like right here, I think there's probably multiple entries for 1. Yeah, there's like 2 entries for 1, 2 entries for 0. And so what we're going to do instead is let's go back to that mutation over here. And we are going to do a very similar lookup. We're going to first get the chest. And then we're going to say if the chest exists, then we're just going to return. We don't want to insert another chest if it already exists. Okay. So now what we could do is check this out. I'm going to go ahead and clear out our Convex database right here. I'm going to delete all these records. And I want to show you that Convex is a real-time database. So as you delete things from your Convex dashboard or other users might be doing stuff, it's automatically going to update any UI that's subscribing to that data. So if I were to load up 2 pages, let me show you. I'm going to click on the left and you'll see on the right stuff update. So this is automatically syncing between all the users in your application, which is again one of the reasons why using Convex for this type of application is so awesome, because you can have everyone just stay in sync and get those real-time updates and you don't have to do much work. Okay, it's all subscribing to the same type of data. All right, I'm gonna go ahead and commit what we have so we don't have so many open and change files. I'm gonna say ability to click on a chest and we'll commit that. Okay, so another thing I wanna do is some of these chests need to have like a discount coupon code. And I think what would be cool to do is we could potentially just have a hard-coded list of chests that are considered discounts. So I'm gonna say const discounts is equal to, and then we're just going to go ahead and add different indexes. So I'm going to say 0, 5, 10, and 20. And so if you were to select one of these chests, I need to show a discount code to the user because they've won. And now that I think about it, maybe it'd be better to just do this so that we can actually add the code. Okay, let's just do that real quick. And we'll do this a couple more times. How about just 2 more times? And we'll say index 3 and index 20. Actually, instead of calling it discounts, I'm going to call it gold chests. Okay, so now let's go down to when they open the chest. And what we want to do is check if the index they clicked is one of these, then we can probably return them back that code. And then we could store that in the browsers like local storage so they don't accidentally lose it. So we're going to say if, actually, I think GPT is telling us how to do it. Yeah. So look through all the gold chests and find an index that matches the one they clicked. And so that should return either undefined or it should return the actual gold chest. And what we could do now is say if there is a gold chest, let's just return goldchest.code. So in the front end, basically, if you open a chest and then we get back a code, if you happen to get back a result that has a code, so if result.code, oh, actually, this will be a code. Yeah, so if it happens to have a code, we're just going to display an alert that says you found a code. Let's try that out. And so let's reset everything. Let's go here and delete all of our items, and then we'll click on the first one. And notice it says, you found a ABC. Cool. So I think what we could do is try to store that in local storage, because if a user sees this and they accidentally close it out, that code's going to be lost forever, right? So I think what we could do is if a code comes back, we're going to say window.localstorage.setItem, and then we're just going to go ahead and say code here. I'm hoping people will only get one code. I'm sure there's going to be someone who's going to abuse the system and write a for loop and just check everything by default. And if that's the case, then I guess they're going to get all the codes and they can just do what they want with them. But what we're going to do is we're going to store that code in local storage, but we're also going to store it up here. So we're going to go ahead and just say like const code and set code equals uState. And then we're going to go ahead and just default it to the code that might exist in local storage. And then we can display it. So over here, we can go ahead and say like, we'll do another paragraph tag. We're going to say you found a code of, and also we need to pass set code as an argument here so that when the chest happens to find it, we can like do something with it. Let's just go ahead and pass it in here. We'll say set code is a dispatch. And then we're going to go ahead and say set state action, string, or let's just do this. Okay, so now if we do get a code back, we can also just set it like this. Now that I think about it, maybe a cleaner approach would be changing this to just say like on code found. This could be a callback. And we'll just go ahead and pass in the code as a string. And it's a function that does nothing. Again, abstracting your code away a little bit can be very useful so that this thing doesn't need to know about local storage at all. Instead, we're going to go down here and we're going to say on code found. This is going to be a function that does all that. And then this will take in a code. Does that make sense? Like just keep the idea of like local storage out of this whole component and just give it a callback function. And so if we do find a chest that had a code in it, it should store this in local storage. It should update our state to store that here, which should update our page to display it here. And then we also show an alert, which should probably say, you found a discount code for my starter kit walkthrough. All right, I went ahead and just displayed some text so like I can show them the code and then say like you can get my starter kit with the discount with that code. Okay, so this is the text. You found a code. Use the code of blank to get a free copy of my starter kit. So right now I think we only want to display this if code is defined. So we're going to go ahead and just like wrap this whole thing. And now we'll display. And the difference is if I were to go ahead and just like clear this out. There we go. We're going to go ahead and just click on this. We get the alert. You found a discount code for my starter kit walkthrough ABC. Click OK, and then it stores it in local storage so that when they come back, it is still there. And I might change the color here. So I'll say text blue of 400 or something, just so people know. And then this class name, I could just give it a link, I think. That just goes to Google right now, but we'll add onto this. Awesome. So some more things we should do is when this chest was open, we want everyone to know that this was like a gold chest. Okay, so someone found the gold chest. Now the way we could do that is in the query, we're going to go ahead and return the chest object, but we also wanted to note if this was like a gold chest. So I'm going to go ahead and just like spread this and say is gold. And then we're going to find to see if this was one of the gold chests. So if the index of chest happens to match the index that the user is like looking for, actually I'm going to call this chest, then we're going to go ahead and denote this as a gold chest. And let's go back over here. And I think what we could do is where we display the chests, we have is gold now, which might be defined. And we can just say if it's open and if it's gold, then we can just display yet another image. I know this is getting kind of nasty with the ternary, but I can go ahead and just say chest of gold. And now we have a gold chest that's been opened. Okay, our logic is not working good, so let's go back and fix the logic. Also, I'm going to go ahead and just disable this for the entire file. That lint error is getting kind of annoying. But yeah, so there's something wrong with the... Oh. This needs to be chest.isGold. I forgot to put that there. There we go. So now as users open chests, you will see that the gold ones get displayed over here. So this approach will work pretty well, but the issue is as you keep adding more and more chests, like right now we have almost 100 subscriptions to Convex, and if you were to try to add 1 million, I guarantee you're going to get rate limiting or you're going to get issues with stuff just being laggy. And so now we have to kind of rethink of our solution to make it store less data in Convex, because you don't want 1 million of these chest records being stored. I mean, it can handle it, but is there a way to simplify this? And then also, is there a way to just like do less subscriptions? Because every time you subscribe to a key in Convex, like they have to keep track of that in memory, and then they have to publish an event to you when that key were to change. So one cool technique that you may or may not already know is something called bit sets. And I want to point out that we have all these chests that are basically represented as an individual row to know if it's been open or not. Like this is open, it's kind of redundant, honestly. But instead, what if there's a way that we could use an integer and every bit of that integer represents if a chest has been open or not? So if you don't know how bytes work, let's just go ahead and say integer. An integer is made up of 32, typically 32 bits, okay? So let's imagine 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to do this 4 times. So 8, 16, 24, 32. So this is a 32-bit bit integer, which is also called 4 bytes. Each of these is a byte. And what you can notice is that all these could represent a chest themselves, right? We could say, okay, this chest is open if this is a 1. This chest is open if this is a 1. This chest happens to be closed if it's a 0. And so this is called a bit set. When you encode these flags in an integer, and each bit represents a different like Boolean, it just saves a lot of space. So now instead of having all these records in our database, we can have a partition, I guess you could say, of these chests from here all the way back to the start. This could all be represented with a single 32-bit integer, which is going to save a lot of memory in our database, and it's also going to make the UI not have to subscribe to so many different records in Convex. So now let's go ahead and try to understand like how a bit set works. The first thing in a bit set is you need to be able to turn on individual bits. So the way that you can basically do this is we're going to declare a number. And we're going to go ahead and just say this is going to be the number 1, right? This is 1. This is the integer 1. And for example, let's say we wanted to turn this one on. Okay, how would we turn this space on by using this number? Well, we can do something called bit shifting, where you take this number and we're going to shift it over 1, 2, 3, 4, 5 places. So we're going to say 1 shifted over 5. And that is going to basically move that 1 to this location. And so if we wanted to take this number and turn on this bit, what you could do is to do a logical bit OR. And so that's going to say if this thing is either 1 or 0, and if this thing is 1 or 0, then the outcome is going to be 1 for that bit. And then ultimately you'll get a number down here, which is going to be, let's see, this would be 2, 4, 6, 8, 16, 32. I think this will be 32. Now let's just verify that that logic I just taught you is right, because I'd hate to be teaching you something wrong. So we're going to go and just load up node. So we're going to make a number. I'm going to say let bit set is equal to 0. Now, if you wanted to visualize what the bit set is, you basically say toString and you pass it a 2, and that'll tell you like the actual bytes. And so if we wanted to turn on that 1 bit I talked about at that location, you could just bit shift it over 5, I believe. So 1, 2, 3, 4, 5. So let's say bit set is equal to bit set or 1 shifted over 5. And now let's print it out. And this is what that binary format of that number is. Okay, so we're going to be doing this type of logic to basically toggle it on now. And instead of storing like a record for every single one, we can store like partitions. So let's go back to chess and the schema. We need to kind of refactor how we're doing this a little bit. So we're going to refactor this code a little bit because instead of having an index for every single chest, I'm actually just going to give it a bit set like this. I'm just going to name it bit set. It might be kind of confusing, but I think this should be good. But then also instead of index, I'm going to call this partition. Okay, and this is how we're going to check if it's the first 32 chests, if it's the next 32 chests, etc. And then is open can go away. And I think we're going to have to change this to be by partition. This can also be a partition. Okay. So we'll have to do some refactoring in all of our code, but it's fine. This is an iterative learning experience. So over here, instead of saying with index, we actually need to figure out what partition did the user click on. Okay, and so we can kind of compute this. If this was the original box number or the chest number, we can actually get the partition by saying math.floor and then take the index they passed in and divide it by 32. Okay, and the reason we're doing 32 is because there's 32 bits in a number. So I'm going to say const bits in partition be 32, and we're going to go ahead and just divide that. And so this will give us the actual partition number, and then we can say get this by partition, and we'll say partition, and then we're going to pass in the partition now. Okay, so instead of this being chest, we're going to call it chest partition. And I think we need to change up this logic a little bit, because now we're going to say if the chest partition was not created yet, then we probably need to create one. So let's just move this up here like that, and we're going to insert the partition. And the bit set could be 1, and then you shift over the current box you're trying to turn on, modded by the bits in partition. So what this is doing is basically figuring out what bit this chest really belongs to. And so we can just go ahead and shift it over. Oh, I think bit set, actually this needs to be number. I messed that up. And technically, if you look over this, it's saying that this is actually a float 64. So I think we might actually have 64 bits we could play around with. I'm going to keep it 32 just for now to keep it simple. But yeah, now when we insert this, if the chest partition is not defined, let's just create one and just turn on that bit as true, okay? Otherwise, what we need to do is we need to basically update the existing partition. So I'm going to say chest partition dot bit set, and then we're going to do an or equals, shift that over, and again, that's going to turn that bit on, and then we want to persist that. So I'm going to say await context db dot patch. We're going to say partition of ID. I'm sorry, chest partition of ID. And then we can just go ahead and patch in the bit set like this. Okay, so if it doesn't already exist, go ahead and create it. If it does, just flip that bit on. And then finally, if the index the user is trying to turn on happens to be a gold chest, we're still going to return the code. Okay, so the logic's a little bit different. And now the main benefit, like I said, is now we're storing a lot less data to know if these chests have been opened or not. So let's move on to trying to refactor get chest. Now the issue right now is that in the UI, it's going to make for every single chest, it has to basically subscribe in convex to if these chests change, which with how many chests we're displaying on the page, maybe it's not that big of an issue. I mean, this is like maybe 80 or so. But if we're trying to be like, you know, squeeze out as much performance as we can, maybe what we should do is instead we can do a get chest partition. And so the front end can figure out, okay, where does the chest belong to? And then we're going to go ahead and just say partition here instead. And we'll pass in the partition. This will get back the chest partition. If there is no chest partition, we return null. Now, an issue that I just recognized is that I think we're returning if a chest is gold or not, even if the user hasn't opened it. So I would hate someone to be able to go to the network tab and like discover if, you know, one of these chests happens to be gold. And so what I would probably recommend doing is making a separate query to know what gold chests have been open, and if they have been open, we can display the index. So let's just go ahead and get rid of is gold for right now, and we're going to do some refactoring. And we can just go ahead and just return the chest partition like this. Let's keep this simple. Okay, so this will have a bit set on it and a partition number. And so now let's go to the UI, and we're not going to worry about the gold stuff just yet. We'll have to come back and figure out a better solution for that. But over here, for every chest component, we're going to go ahead and just get the chest partition instead. Okay, so get chest partition, and instead of index over here, we need to pass in the partition, which again will be math.floor. And we can actually import this. So I'm gonna go ahead and just say bits and partition so that we're not like, keep the code dry a little bit. So let's just go ahead and import this. And then we can go ahead and say, how do we know if something's open or not? All we need to do is check that one bit. And so we haven't done this yet, but basically what you need to do is get the bit set and it with the one that's been shifted over. So this is a bitwise and we're doing the same approach with the OR, but basically take that one bit, shift it over a little bit, and then mod it by something so that we can kind of like have all these partitions correctly lay out. So we have to go over here and say if this is defined, we can do this. Otherwise, we're going to say it's not open. Okay, so disabled, what is this saying? Number or false? Oh yeah, then we need to check if it's on. So I'm going to say if it's not equal to 0. We probably want to wrap all this stuff. Now we are getting a little issue here. I might actually take this out and call it bit, just so the code's a little easier to understand. And then we're going to shift this over. And then we want to make sure that if this whole thing is not equal to 0, then we know that this box has to be open, right? The only way a box can be closed is if the bit is 0. Okay, so now the last part, let's just go ahead and hardcode this to false for right now so we don't have issues with the gold chests. Now, sometimes when you change schemas in Convex, like unless you go and modify your data first, Convex will not compile because it doesn't know how to run a migration script for you. And you'll notice here in the Convex CLI, it's actually crashing. And so what we're going to do is we're going to go back over here to data and let's just delete everything. Let's just delete all the chests. And now we can go back to our UI. It should work. And let's just go ahead and click on a chest and see if it, okay, we got the code. Awesome, the chest is open. Let's go over here and notice that the bit set says 1. And as I'm clicking more chests here, you'll see the bit set is going to increment to various numbers. Okay, we got another code. There we go. And at some point, if I were to check all 32, we'll get like the max value of 32 bits being on. But if I were to go down and scroll down and click on like one of these, notice that it's going to create a completely different partition. So partition 2. And it's going to turn on the bit that represented that chest that we opened. Awesome. So basically all these chests are displayed with probably 3 numbers, which is a lot more efficient in terms of our data. But now we have an issue with the gold chests. Those aren't being displayed anymore. And the reason I kind of refactor that away is because I think we were potentially leaking over information about what chest was gold. And so what I'm going to do is I'm going to add another query here. I'm going to say const get gold chests is equal to query. And this will just be, this won't take in any args. It'll just be an async handler like this. And we only want to return an array of the gold chests if they have already been opened up. So this might be a little bit more complicated, but I think it's a lot better to know like what chest has already been opened. So what we need to do is we have this array of what chests are gold. And I think we're going to have to go and look up every single chest to see if it's been opened or not. Because it hasn't been opened, we don't want to leak over what index someone can potentially open to quickly get the coupon code, right? And so what we could do is write a helper function called like function get chest, or is chest open. This might be kind of useful. And this is going to take in a query context. This is like the convex thing, and we're going to go ahead and say like, give us the box number. Let's read through Copilot and see what it's doing. So basically it's saying figure out the partition number, get the bit. It's going to look up that partition, and then it's going to check if that thing has been on. So I think it's close enough, but we're going to change some stuff up over here. Basically get the partition, that's correct. And then we want to basically return if the chest partition dot bit set and bit not equal to 0. Yeah, I think this actually works pretty good. We just need to wait on it, put an async here. And now we have a helper function we can call inside of here. So what we need to do is I'm going to say const chest is equal to await promise.all. And then we're going to say gold chests dot map. And then for every single one, we're going to return an object called isOpen. And then we're going to call isChestOpen, and then also we want to call back the index. which could be chest.index. Okay, so again, this is like, let's say we have 3 gold chests. It's going to query and see if those chests have already been opened by somebody. Now, I think what we could do is this will have like an array of a bunch of chests, and we're going to go ahead and just filter that down. So I'm going to say const only open gold chests is equal to chests filter. We only want the open ones, and then we're going to return that. Okay, so a little bit confusing, but I think this will be a much better approach because now we're not leaking information about what chests have been opened. So now, over here, we're going to say const gold chests is equal to use query. We're going to say API chests.get gold chests. And now this should be an array of things. I think we should just have it defined to an empty array if it's not fully back from the database yet. And how do we know if it's gold? Well, we can just say if this thing matches any of those indexes that we're currently on, then we should be able to display the gold chest. Okay, and there we go. We have some gold chests that are being displayed. And if it hasn't been opened, we won't get any information back. So I think we're making some really good progress. I'm going to go ahead and just make these changes. I'm going to say converting, use a bit set. So one thing I noticed is that as you open chests, like we don't know how many chests have been open or not. And the issue with what we have with the bit set is the only way to figure out all the chests that have been open is we have to query every single chest in our database, loop through the bit set, figure out and count all the ones for every bit, and then sum that up. Not the most performant, especially when you get to 1 million chests. Like you can't just query 1 million records and recompute that every single time. It's going to be very, very unperformant. And so one approach we could potentially do is we're going to add a sum. We're going to add a new table called sum. I guess I can call it sums. And let's just define a table like this. And it's going to take in a value. That's it. Okay, so we're basically going to, every time someone turns a bit on, we're going to increment a counter somewhere. Now that we have this table, we're going to assume that we're going to manually just create one record. So like we can just go over here and go to sums. I can just add one and just set it to 0. And for right now, what our app can do is just like fetch the first one it finds. So I could say like const sum record is equal to await context.db.query sums, get the first one. And again, we're assuming it's defined. So like we could just say sum record dot value plus plus, and then we need to write it back. So let's just go ahead and patch that like this. So let's try that out. Let's just go ahead and delete all of our chests again. And we are going to go ahead and just start clicking some stuff. Let's just click on the first one or the second one. And then we should see that this gets incremented to 2. Okay. Should be 3, 4, 5, 6, 7, 8, 9, 10. Over here, it's set to 10. So we're basically keeping a separate record that we update every time someone clicks on a chest. So we can display that in the UI. So let's make a new file, and I'm going to call it sums.ts. And then we're going to say export const get open box sum equals a query. And then we're going to go ahead and just query that sums table, get the first record, and send it back to the front end. So now I can call this query, get open box sum. And I think we can call it over here. So I'm going to say const open box sum is equal to use query. And then we're going to say api.sums.get open box sum like this. And I think this will also default to undefined when it's still loading. So I'm going to make it 0 and we can display it. Okay, so let's go back to the UI. And as I click on chests, notice that this will update. And it also will update to anyone who's currently on the application using it as well. So now let's move on to the interesting part of how do you display 1 million images on a DOM page. Now, honestly, this won't be possible, right? Your web browser will actually start slowing down. And like as users scroll, like it'll just lock up. On top of that, you'll have tons and tons of queries that are happening. Stuff will be trying to update live as other users are clicking on chests and stuff like that. And so we're going to use virtualization so that people can scroll through all these records and we won't actually have to display that many on the page at once. So we're going to go ahead and just install React window over here. And I'm going to go down here. Let's just say bun add React window. And let's look at some examples of how this works. So basically you can have a virtualized row with like a lot of data. They also have a fixed size grid, which I think is what we want. We want to have a grid of chests. And so we're going to import this fixed size grid from React window. Just do this. I think I'm missing some types, so let me also bun add that. And so the way this works is instead of looping over all these chests, what we can do is give it a grid, and then we can start passing some props here. So for example, you can give it how many columns are going to be in this thing. So in our case, we could just say like, I don't know, 14 maybe. You can say what is the column width of all these? Probably 64 might have been good, maybe, I don't know. Height, again, this will be the height of the entire scroll grid. We'll say 400. Width, we could say 600. And then we're going to say row count. So for row count, we need enough rows to basically be able to handle all these checkboxes. So one way we could do this is basically figure out the total amount of things we're going to have. So like number of chests divided by how many columns we're going to have. So I might actually start pulling stuff out here. I'm going to say const column count is equal to 14. And then we can divide this by 14. And that's how many rows we're going to need. And then for row height, probably 64 as well. Now this thing also requires a child. So like we can just go ahead and pass in that chest object that we talked about before. But unfortunately, we're going to have to like refactor how we're doing some of the stuff. So I think we still need to pass in like an onCode found thing. So I could say onCode found is going to be a function, which we can do the same logic. And let's just delete some of the stuff. This will be a string. Okay. And so for chest, the reason this is red is because there's some stuff that we still have to like allow to come in as arguments. So like, I think we need a row index, and then we need a column index. We're definitely going to need a style, and then we're going to need data. So like we have to kind of refactor how some of this stuff kind of works. Just go ahead and put the types here. Make sure we're kind of on the right path. Now I think the first thing we're going to do is we're going to have to put this style on a div that wraps everything so that the React window knows how to properly like position everything, because behind the scenes the virtualization is going to like do positioned of absolute and give it like left and top positions. So this thing definitely needs to be added to our div. Secondly, I think over here onCode found will exist on data, so we have to make sure that that is correctly set up. And so now we have some issues with index. Before index was passed in, but now we need to compute it based on the row index. So I'm going to say const index is equal to row index. This is 14, so I think what we need to do is move this up. So column count will be 14, and then we'll do column index. And I think one thing we're going to have to do is basically say if index is greater than number of chests, then just return null. Like we don't want to render out a bunch of empty buttons that don't do anything. So there's no errors on our TypeScript, but let's make sure this works. Okay, we have a bunch of chests here now. So it is displaying. I think there's some things that we're going to have to do to like make this look nicer. I think we're going to have to expand some of these things. So like column width and column height. I might go ahead and pull these out the constants as well. So const column height is equal to 128. Const column width is 128. Okay. Actually, let's just make them match basically the size of these buttons. So we have height of 24 and 24. What is that? The button is 96 by 96. So I think what we could do instead is do like 98 by 98. Maybe even 100 by 100. So this is cool, but the issue is like based on different sizes of your browser, like you don't want all of these things getting smushed over to another scroll bar. It's kind of annoying. And as we expand, it would be nice if these chests would go like full screen. So there's another library that we can bring in called React Use. So I'm going to go ahead and just bun install that as well. So bun add React Use, and then we're going to go ahead and import it. Let's say const use measure from React Use. Oh, sorry, import, not measure. Okay. And what this allows you to do is you can actually like bring in a ref, a width and a height, and we can attach it to a div element. Okay, and so we're going to go and put it on the div that is holding all this stuff. So I'm going to put it right here. I'll say ref is equal to ref. And then technically this thing, we could give it like a width of full and a height of full, maybe. And let's make sure this whole thing should be full width. So the first thing we want to do is how do we expand all these chests to be like all the way to the full screen? So I think what we need to do is we'll have to dynamically change the column count based on the width of the screen. So I think over here, so over here we know how wide each column is. So I think we can say width divided by column width. And let's just go ahead and seal that. And I think for the height and the width, like we could actually just set this to width, sorry, height. That could be width as well. Let's see how this looks like. I notice we're passing column height instead of row height. So I'm going to say row height. And just define that just in case for whatever reason the height of the columns and the rows diverge. Definitely want to do that. Column count is no longer going to need to be hard coded. I think for here, we're going to have to pass in the column count. So column count is going to equal to a number. And we can say data.column count like this. Means we're going to have to pass in a column count over here. Column count is equal to this. Okay. Row count is going to be equal to the column count, which again, we'll have to do something like this. I'm going to change this to H screen. I think that'll might fix our issue here. And it's kind of weird. There's a little bit of scrolling going on there. So I think I might actually need to, I do notice there's some padding on the actual main. So I want to get rid of that. Let's find where main is. And then we're going to get rid of that padding here. Okay. And then also we can scroll a little bit on the side. That's not very nice. So let's go back to the main page. And I think we're doing like a math.seal somewhere, which I don't think we want. We probably want a math.floor. Okay, there we go. Okay, so moment of truth. If we were to add in a bunch more chests, this whole thing gonna fall apart. So for number of chests, let's just try 5,000, make sure it doesn't crash. Now you can scroll down, we can see all these chests. Okay, you can click them. Just verify if you go to the very last one. Can we click on the very last chest? That seems to work. I'll load up a new tab. Let's go to the very last one. There it is. They're open. All right, this is actually really good progress. Let's try 1,000,000 now. This is the moment of truth. Let's do 1,000,000 chests. And now we should have 1,000,000 that are showing up, which is going to be quite a lot of chests. All right, let's just go ahead and say adding in virtualization. Go ahead and commit that. So one thing you might notice is that I have all the gold chests basically hard-coded in this code base. Not the best approach. And so it would be better if maybe these were defined as environment variables and we could basically just set them as like a number, comma, code pair separated by semicolons or something like that. And so what we're going to do is let's go back to convex and we'll add gold chests. And we'll say index 5 is a code of hello world. And then we'll say index 10 is GG. Let's go ahead and save that. And then we could potentially just do a process.env.gold chests. Force it to be defined, split by the semicolons, and we can map over everything. Okay. And then again, this will be like a string that we find. And we can say s dot split on the commas, and that'll give us back the index and the code. And then we could just simply return index in code like this. And I think this should hopefully work. Oh, but index needs to be parseInt of index. Like that. And I think there is an issue like this actually probably has to be lazily evaluated. So I'm going to say get gold chests is going to be a function that does this. So let's just go ahead and return this. And I think we could just call it like this anywhere that we're trying to get it. Oh, I need to name this something else. I'll just call it get gold chests env, I guess. I don't know. And then we'll have to call it here. I think we'll have to call it here. Okay. Hopefully that's happy now. Let's go ahead and refresh this page. The 5th one should be a gold chest. Here it is. And then I think the 10th one, there it is. Okay, we could also probably stringify a JSON object and just put it in here if this approach is kind of weird, but it works. And we could basically put our discount codes inside of that variable, and that'll be lazily evaluated when the mutations and queries run. So I do think this app is basically done. I mean, I could probably get this deployed out, but I do want to spend some time to talk about database performance, because when it comes to scale, let's say this thing went viral for whatever reason, and we had a bunch of people coming in here trying to basically click on checkboxes all at the same time. There is something called database contention. And basically in SQL and other databases, including Convex, if you use transactions, you can have multiple things trying to write to the same record at the same time, and then your counts could be off, right? Right now, everything is synced up because Convex is using transactions under the hood. So even if multiple people are clicking on the same checkboxes at the same time, the counts will always be correct because they're using serialization for like the transaction level. They're also retrying mutations if there is some type of conflict, and they use optimistic concurrency control to kind of resolve that. But with that stuff being in place, that means that if a bunch of people are trying to modify the same partition at the same time, you may see some issues with these counts because we're trying to write to the same count record over and over again. Remember in our code base, we say just look up and give me the first. Well, unfortunately, that works for low traffic, but for higher traffic, you may run into issues. And so I do want to try to simulate that. I think one way we could simulate that, let's just add a use effect here. And then we're going to go ahead and say when this thing mounts, I'm going to say set interval. And we're going to do something every second. Probably should clear it up as well. So I'll just say clear interval. Interval, and past that. Okay, and so what we want to do is we're going to randomly check a checkbox every second. So let's just do open box sum. We can just go ahead and call this, and we want to give it a random index. So I'm going to say math.floor, math.random, and then number of chests, which should be 1,000,000. Okay, so it's just going to randomly pick some chests. Oh, actually, I need to, where's the mutation? I think I need to get this mutation over here, open chest. Okay, so let's bring in that mutation. We'll say open chest. And I think this needs to take in an index, actually. Okay, so now if we go back to the app, notice that it's slowly incrementing and opening some chests. But if I were to make this go a little bit faster, let's just try 100. You'll see these values are keeping up pretty fast, right? But if we were to make it even faster, let's change it to a 10. Is this thing going to keep up? Now, for the most part, I don't think I'm going to be able to simulate like enough traffic for this to be an issue. But if you had, let's say, tons and tons of people like opening boxes at the same time, like even with 100, this thing is working pretty well. Like it's able to keep up, and that's a lot of checkboxes. Like this thing would have to go mega viral really quick to be able to increment that fast. But I do want to kind of talk about contention on the database and how would you potentially, implement a solution to make this be able to handle a bunch of traffic at the same time. So the main areas of contention I'm seeing with this implementation is that when someone opens a chest, so let's go and find that mutation. When someone opens a chest box, what happens is I'm doing a query and say, give me the sum record, give me the first one, and then go ahead and just update that again. Now the issue is that if you have a ton of people opening chests at the same time, the way Convex works is that if the mutation does a query on a table and it notices that before it's committed to the database that the sum has actually changed, it's going to have to retry the mutation. Okay, so you end up getting like behind the scenes this queue where it can only run one mutation at a time because you have all this contention on this sum record. Not the best. And so what you end up needing to do is instead of having one record where you basically sum this up, you need to add multiple things. So like basically partition your data up. So we could actually add a couple of these. Let's just add 5 just to kind of simulate. And now instead of just picking the first one, we're going to pick a random one. And how could we pick a random one? Well, what we could do is we could add a special index to the schema. Let's go to sum and I'll say index. This could be a number as well. And then we're going to add an index over here called by index. Index. Okay. And so instead of just, like I said, getting the first one, let's extract this to a helper function. And I'm going to say function increment count. And this will take in a context of a mutation context. And we're going to run this code. And instead of saying first, we're going to say with index. We'll say by index. And so instead of saying give us index of 0, we're going to say math, we'll say random index is equal to math.floor. And then we're going to say there's how many are there? There's 5. So we should probably extract this and say const sum partitions is equal to 5. And we're going to grab a random one here. And then we're going to increment it and then we're going to repatch it. So it's almost the same logic, but the main difference is that now we don't have contention on just one sum record. We kind of fan that out so that there's less chance that a query is going to be grabbing data that might be changing by other things. And so like you can get a bunch more throughput by just adding more and more of these type of records. Now, since we changed how that's kind of working, we have to figure out the sums. And so get open box sum. Right now, this is doing a first, but really we need to get everything. So let's just collect everything. And then I think we could probably do some type of reduce on it to sum them all together. Okay. So we'll say sum records and we'll reduce that. So let's make sure this still says 1041, go over here. And as I click on different things, we should see that it picked random indexes to update. And then of course, this is crashing, so we will have to reset this a little bit. Let's just go ahead and reset that. Let's add in an index now. Okay, so this would be index 0 with a count of that. It'll be index 1, index 2. And again, this is just a manual setup you're gonna have to do like before you go live, but it gives you the flexibility to add more if you notice that there's like slowdowns with stuff. So now let's go through and let's just reset all the chests as well. Delete all these. And let's just click on some stuff. We won one, okay. Click on some of this, awesome. And now let's go back to sums and notice that now we have 5 different records. They all have different count values. And like I mentioned, we randomly pick one just so there's less contention on writing to the same record over and over again. This is a good concept. You're going to need to understand this when your data reaches like certain scale. But for the most part, do it later on. Like do it when you notice there's an issue, not up front. Now, the very last thing I want to do is that I do notice that when I click on one of these boxes, there's like a little delay. And I think adding an optimistic update to basically toggle it open right when you click it would be a much better user experience. And so let's go back to our app and let's find out where we are opening these things. So over here, when you click on a chest, we open the chest. Turns out that Convex has a built-in way to do optimistic updates. So I'm gonna say with optimistic updates, and we're gonna go ahead and just give it a function. And the way this works is you pass it a local storage, or sorry, a local store in an args. And the local store allows you to access the underlying query caching that's happening with the convex use query. So I'm gonna get the current value of the local store.get query of get chest partition. We want to get the same partition over here. This is probably better if we were to pull this out. So partition index is equal to this. Okay. I think this is actually get query. Okay. So that'll give us the current partition. All right. And then what we want to do is we're going to basically optimistically update this if it's not defined. So let's just go ahead and do a local store dot set query. We're going to pass it that same query. So chest.get chest partitions. We're going to pass it the partition index like this. And then we're going to pass it the optimistic data. So over here, we should be able to set the new bit set. It's probably also missing something. I think we want to do this. So I know there's a lot of code, but basically what's happening is the moment you click on a chest, it's going into the convex like cache that's on the front end, and it's just like updating the value to match what we think it should be. And then when that's done updating, when like the query comes back with the new data, if they match up, then everything should be good. So now if I click on something, it instantly opens. Okay, and that just feels better in my opinion. Now the only thing is like when you open a gold chest, there's going to be a little delay for when that gold pops up, but I think that's fine. Cool. Let's just go ahead and commit this. I'm going to say adding optimistic updates, and some partitions. So now what I would like to do is I want to get this deployed out to Railway. It's what I like to use for deployment applications, but you can use whatever you want. And that's mainly just for the Next.js application side of things. The Convex side, it's already kind of deployed out. So I'm going to add in a Docker file. This is what I kind of use to deploy out my Next.js applications. The only thing we need to make sure is set is next public convex URL. So we are going to go here and just say arg and make sure that that is set. And second thing we need to do is in the next config, we need to say output is standalone. Okay, so now we should be able to basically deploy this thing out to Railway, and then it should know how to point to convex because of this environment variable that we're going to pass in. So let's just go ahead and say adding Docker file. Go ahead and sync that up. And we're going to point this to that repo. So let's find million chests. I'll say add variables. And we're going to have to actually go to production on convex. So let's switch this to prod. Over here it says production. And now it's going to provision a production environment for you. A couple things that we're going to have to do first is we're going to have to go to settings and add that environment variable for gold chests. And let's just say index 0 and just a code that says like hello world, whatever. We'll save that. And then we should get a different environment variable that we need to use to kind of point to this. So if you look at our current environment variable, it's doing adorable owl. That is not what we want. We want wonderful alligator. Go to Railway. We're going to go ahead and just paste in this variable. And then we're going to go ahead and just put adorable owl for now. And then we're going to go back and get the wonderful alligator. It's our production link. Okay, go ahead and add that in. I think it should be good. Wonderful alligator convex.cloud. Okay, so now let's deploy it out and let's see if we get a URL that we can use to kind of check this out. So while that's running, we actually need to deploy convex to production. So I'm going to say npx convex deploy. And that is going to ask if we want to deploy to wonderful alligator. And then we'll say yes. And that's going to apply and create the schemas and create our databases. So let's go over here and look at data now. We have chests in some. Again, we're going to have to add in at least 1 or 2 so that it's happy about that. Okay, we'll just add 2 for right now, or maybe 3 in case this thing does go viral. I don't think we'll have an issue though. And yeah, I think we're set up for that aspect. Now let's make sure that we can get million chests deployed to Railway. Actually, one thing that we typically have to do is add a port, and we'll say 3000 so that Railway knows how to actually get to our Next.js application. You know, my issue is that I was doing bun for all my development, and right now we don't have a package lock. So I'm just going to bite the bullet and just do an npm install so we can get that package lock, and so it can actually run everything with Node instead. I personally haven't ran Next.js with bun on production, so maybe I'll come back at a later point and just try to figure out how to get that going. But for right now, that's, I think, all you need to do to get this running with Node.js. We're getting a little error saying window is not defined. So unfortunately, I think we're going to have to say use effect because you cannot with Next.js like access window. So I'm actually going to say use effect set code is equal to this. If the code is not defined, I'll just default it. And then here we'll say this is a string equal to nothing. In fact, I can just default it to nothing. All right, let's try it one more time. Removing window. Okay, so while this is still trying to deploy, what I'm going to try to do is I'm going to set up a custom domain. And I'm going to say millionchess.webdevcody.com. And I want to see if I can get this set up correctly. So I'm going to add a domain. Okay, and they're going to give me a CNAME. And let's go to my WebDevCody on Cloudflare. This is where my domain is kind of set up. And I think if I go to DNS records, I could add one called CNAME. And we are going to add in million chests like that. And then we're going to grab this for the target. And do we want this to be proxied? I guess we could. Let's just save it and see what happens. And yeah, let's just go ahead. So this is taking a while to deploy. So while that's deploying, I'm actually going to go and try to add one more feature to this. I think it'd be cool to see, like, tease the user to say, hey, there's like 5 more gold chests remaining. And right now, where's the gold chest? Get gold chests. Right now we're doing that query here, but we could also do it at a higher level, I guess. It's like we could do it here. And we could just count how many. We could potentially just like say there's going to be a hard-coded amount. So I'm going to say const total gold chests is equal to 10. Okay. And then over here, we could just say there's like so many left over. So I'll say like, okay, so now it actually says how many gold chests we have found, which is pretty cool. So it kind of gives people an incentive to like, okay, can we find those other 2 gold chests? And I might just commit that up. So I'm going to say display gold chests opened. All right, we have a successful deploy. Let's first of all go and see if we can access this. So let's go to settings and click on this link. All right, there we have it. So it is fully running and it's in production. So if I go to production over here, as we start clicking on these chests, cool. And so now we can actually like open up some chests. Let me just make sure if I click on index 0, the code pops up. Pretty cool. And now I'm going to reset prod because I don't want these chests to already be open when I make this video. And I also delete these chests. I think the very last steps for me is I just need to basically update 10 of these before I go live so that people can actually find coupon codes. All right, so I hope you guys enjoyed watching me implement this. I think this is a pretty cool application, and Convex is where stuff shines when you start having real-time data that needs to be updated for tons of users using your application. Like always, the code will be in this repo. I will put this in the description of the video. And finally, be sure to go check out Convex, create an account, and play around with it. I guarantee you, you're going to really like how everything is just super easy to create backend endpoints. They also have additional things such as like file uploading. They have vector searching if you're doing AI type of stuff. They have a scheduler, which is really great for doing asynchronous behind the scenes queuing. It's a really good product, and we use Convex for Project Planner AI, which is another side project that you might have seen me talk about on my channel. So I definitely recommend Convex. And yeah, I hope you guys enjoyed. Have a good day. Happy coding.